All right, welcome to 16.5, Properties of Similar Triangles. The word similar in math has a specific meaning. It means that objects are the same shape, but they are different sizes. They are similar, right? Congruence, they are the same size. I'm usually going to skip this warm-up because I changed the order of these lessons and this warm-up does not apply. We're going to learn how to do dilation a little later in the year. So this is an example of three similar triangles. These are the same exact triangle in different sizes. So let's look at them, right? All three have a 90-degree angle. They all have a 53-degree angle. They all have a 37. They're the exact same shape because of that. Now, but what's different? The sides, right? This 6, well, I took 3 and multiplied it by 2 and made 6. 5 times 2 is 10, and 4 times 2 is 8. I made this one twice as big, and we call that the scale factor. The scale factor between these two is 2. We multiplied it by 2, that first one by 2. Then I made the third one, right? And look what I did there. 4 times 3 is 12, right? 5 times 3 made this 15 over there. And 3 times 3 made this 9. So this one's 3 times as big as the original one. If we're comparing it to the original one, you would say it's 3 times as big, or a scale factor of 3. Okay, so this is called a similarity statement. So let's look at the first problem. The two triangles are similar, so that means they're the same shape. So that means the angles all have to be the same. So let's fill those in. We have a 90 there, 90 there. This one's 53. Well, this one is in the same location. It's got to be 53. This one's 37. This one's in the same location. It's got to be 37. Now, I could make this trickier and spin them a little or something, but they would still be similar. Now, so what is the similarity statement we're going to write? We're going to write the three corners, or vertices they're called, and you can actually write them in any order. So we're going to write I'm going to write GHJ. Right? Now so this symbol, that little tilde, squiggly line, is read is similar to. And so you have to go in the same order in the other triangle, right? So let's start. I started with G, the 90. So you got to start with the 90 on this side. So we got to have R over there. And then H is 53. So then that was second. So I've got to put T next. You can't just put them in any order you want. And then J was last. So I'm going to put U. And so that's G, you read that as GHJ is similar to RTU, or triangle RTU. All right, so there I'd already written it. So what's the scale factor here? I think I showed this on the last screen, right? Each of these sides is twice as big. Now, on easy ones, you can just look at it and see 6 is twice as big as 3, and 4 is twice as big as, 5 is twice as big as 10. So what does this one got to be? Well, it's got to be 8, right? Because 8 is twice as big as 4. Okay, so we say the scale factor is 2. All right, so typically we use the letter K for scale factor. So now let's look at this. If PQR, triangle PQR, is similar to triangle MNO, find the scale factor. Well, right, the angles are all the same, right? They're similar, they'd have to be. Now, this one's not so easy, right? 2 went to 3, this 2 went to this 3, and this 3 went to 4.5. All right, well now you can use any pair you want, but 2 times blank makes 3. Uh-oh, that's going to be a mixed number. Well, all you have to do is make a ratio from 7th grade. It's 3 over 2, also known as 1.5, also known, typically we put it as a decimal. The scale factor here is 1.5, right? Now, if you wanted to make it more difficult, you could put 4.5 over 3. If you do that math, 4.5 divided by 3 comes out as 1.5 as well. But you can do just the easiest one. They all should be the same. All right, so what's the scale factor here? Now, you want to put the second one in the numerator, right? This was getting bigger, so the scale factor was bigger than 1. If they were the same size, the scale factor would be 1. So when they get bigger, the scale factor is bigger than 1. This will be smaller than 1. Well, what's the ratio here? Right? We divided by 2, but you don't say the scale factor is 2 because it's getting smaller, right? We have 1 compared to 2, 1 compared to 2. Yeah, we have 1.5 or 1.5 compared to 3. The scale factor here is 1/2. Right? And so what you would typically write k equals 1/2 here, k equals 1.5 here, right? Or equals 0.5, really. Here you go. Now, we previously learned that all the angles in a triangle add up to 180. So if 2 of the interior angles are the same, all 3 have to be the same, right? Because if 2 are the same, the third one has to make them add up to 180, so they'll be the same. So it says the triangles are similar. So I'm telling you the angles are the same. So that means this one has to be 35 degrees here, right? Find the missing angles in both triangles. Well, they have to add up to 180, right? They have to add up to 180 in this one. Whoops, I need an X. And similarly, they have to add up to 180 in this. If 2 are the same, then all 3 are the same. Now, solving this, we're not going to waste our time to solve it again. This has to be 110, and this has to be 110. Similar, well, 110, not 1,110. So, similar triangles, the triangles have to be the same as each other. We're combining that with the knowledge that the angles inside always have to equal 180. So now let's find that missing angle and that missing angle. Are the triangles similar? Let's see. 79 plus 30 is 109. So that missing angle, oops, we're going to subtract it from 180, is 71 degrees. Ooh, over there, right? We have 2 angles that are the same. If 2 are the same, the third one has to be the same. Let's double check it. But if 2 are the same, the third one has to be the same. Rule of triangles. So 71 plus 79 is 150. It has to add up to 180. Yeah. If 2 are the same, all 3 are the same. And you can use that. All right, so find the missing angles here. So these two add up to 138. This missing one, I'll call it X, has got to be 180 minus 138 because they have to add up to 180 inside a triangle. So that one is 42. Oh, 42? Oh, well, this is 43. Well, these are not the same. Once anything is different, this is no, they are not similar. And I forgot to say this. So yes, not only did we find the angles there, but we also determined that those, in fact, are similar. In similar triangles, all 3 angles are the same, and truthfully, if 2 are the same, all 3 are the same. How about there? We have a y there, and a y there, an x there, an x there, an x. So the angles are the same. One is spun a little bit. Does that matter? No. So the angles are the same. One is bigger than the other. Yes, they're similar. So the triangles are similar. Find x. So that's 90. So let's call that y. You can find y first. Pause. So I said they're similar. So you can eyeball it that this is the 38, right? And that one must be the 52, right? If the triangles are similar, the angles have to be the same. All right, so let's start with x. X is this angle. Well, we know these two angles, so we can find that one. So find that angle. That's in the same location as x, so it must equal x. So in fact, let's put an x there. These two are 120 plus 25, 145, right? That last one must be 180 minus 145, or 35. Right? They're similar. So if that one is 35, that one is 35. Similar triangles, the angles are the same. Okay, now let's find y. So this is 3 inches, that's 6. So we multiplied by 2. This is 6.5. 6.5 times 2. 6.5 times 2 is 13 halves times 2. Canceling is 13. Or 6 times, much easier way, 6 times 6 is 2. Times 6 times 2 is 12. A half times 2 is 1. That adds up to 13. So the scale factor here is 2. And so the missing y here is 8. It's a word problem now. It's 8 inches. So try this one. So let's find this. They're similar, right? So if that's 4x, that has to be 4x over there. Right? The 3 angles inside any triangle have to add up to 180. I think x equals 19, right? 4 times x is more than 19, but x there is 19 degrees. Okay, now y. Now notice, 14 times blank makes 42. Uh-oh. 8 times what makes 24? 8 times 3 makes 24. Let's make sure 14 times 3 makes 42. Oh, it does. So we have a scale factor of 3. K equals 3 here. By the way, k equals 2 over here. That's the letter we use for scale factor. So we need something. Y is y divided, right? Y divided by, no, y multiplied by 3. Ugh. Y multiplied by 3 equals 48, or 48 divided by 3 equals y, right? Divide by 3. Here, I'll write it like an equation. 3y equals 48. Divide by 3. I'm running out of room here. So 48 divided by 3. Oh, it's 16. All right, the scale factor. We started with a small one. We made it 3 times bigger. Okay, in both cases, we were making it bigger there. You read these left to right. All right, so let's practice. The two triangles are similar. Find the scale factor. Well, I could compare 2 1/4 to 4 1/2, but it would be way easier to do 2 to 4, wouldn't it? So the scale factor, right, is 2, right? We're multiplying by 2. 2 1/4 times 2 equals 4 1/2. It does, right? 2 times 4 is 8 plus 1 is 9 halves, right? 9/4. Oh, my goodness, major mistake. 9/4. The answer there is 9 halves, or 4 1/2. So scale factor is 2, right? We could have done 1 1/2. Oh, so now we have to do 1 1/2 times 2, right? We're going to have to find that question mark. Right? Find the missing angle inside. Yeah, we're going to have to find that side, 1 1/2 times 2. So 2 times 1 plus 1 is 3. 3 halves times 2. Oh, 1 1/2 times 2 is 3, right? If you have $1.50 times 2 is $3. So it's 1 1/2 times 2 is 3. So that side is 3. And then, oh, I made this really easy. Gave you the 3 angles inside the first one. Well, the angle has to be the same, right? So this has to be 55 degrees. We found the missing angle and the missing side. Write a similarity statement. All right, so now everyone could get different answers here. So let's start with HJK. I skipped the letter I. All right, so I did HJK. So you have to write the letters in matching order, corresponding order. So matching H is N, right? It has to be in the same order. Matching J is L, and matching K is M. So you would read that as triangle HJK is similar to triangle NLM. So are these similar? Let's find out. Well, so far, the angles aren't the same, but we need to know what that angle is right there, and that angle is right there. So let's see. So this one's 50. Now we have two angles that are the same. We have two angles that are the same. That means they're similar. It means this one also has to be the same, right? Now you could do the math if you forget that, you could do the math, right? And everyone would realize that once all three angles are the same, that we have similar triangle. Whoops, what am I doing? Going too fast, right? 10 minus 2 is 8, right? And then, yeah, 98. There we go. Oh, I know what I did. That's what I'm doing wrong. I have to subtract 148, not the, I went too fast. So 10 minus 8 is 2. There is 32. There's what I'm checking. All right, so there says they're similar. So find x. So they're similar. That means this one's also 118. Once you know that, then it's just like a previous lesson. The inside of a triangle, all three angles must add up to 180. Well, x must be 7 there. Right, so they have to be similar. So if that's 38, that's right. They have to have the same angles. That's 38. All right, so now we need to find x there. So 62 plus 38 is 100. Wow, I made that nice and easy. So that one must be 80, right? Because they have to add up to 180. And then I have to find y. Well, 40 to 80 is times 2, so my scale factor, or k, is 2. 22 times 44 is times 2, k is 2. So y times what makes 60? Well, 30, right? K equals 2, so y equals 30. All right.